In this chapter, we will discuss the idea of under a certain condition, I want to take action 1, otherwise I want to take action 2. So this chapter is on decision making in our programs. So the idea here is about alternative action. So the structure we're talking about is a decision structure, which is the computer should take a specific action if a specified condition is true. We consider this to be a Boolean test, which will result in a Boolean value. And the idea of Boolean is the state of either being true or the state of being false. So under the example, if the door is locked, then unlock it, with the idea that if the door is not locked, then I can't unlock it. Same with if the tire is flat, then change it. Otherwise, if the tire is not flat, I don't need to change it. So when we talk about decision structure, then we need to consider what we call the relational operators. We used this in algebra to compare values to each other. And what they return is what we refer to as a Boolean result, the idea of true or false. Relational operators, again, are used to show a correspondence between two values. So the idea here is A equal to B, true or false? Is A, this is not equal to B. So a little different understanding here with the idea, is it not less than, not greater than, but it also can't be equal to. Is A less than B? So that would be the test. Is A greater than B? We have the idea of A being less than or equal to B, and A being greater than or equal to B. Now in algebra, we were able to write less than or equal to as a single symbol, but in computer science, we don't have that as a keystroke on the keyboard. We certainly have them when we're using Word or some sort of math editor, but we don't have that in the keyboard to write an executing line of code. So we use the symbol less than and then the equal sign, or greater than and the equal sign, and order does matter. So we order it the way we would speak it. So we have to also consider the keywords if and then. Now they come together as a pair with the idea that if a condition is true, then I can take the action. But if the condition is false, then I won't take the action. So the test I write must return a Boolean value. So one of those relational operators in the previous slide. The general form is if a logical condition, then take the action. So here's the idea that if grade is equal to 100, then I'm going to let letter $ equal the character A. Another example would be if age is greater than or equal to 16, then I'm going to print driver's license. So the idea that the Boolean test using one of the relational operators, and then what is the action I want to take? What I want you to notice is that we were able to take an action of letting or printing. So any keyword that I have in a regular executing line of code can also be used here as the action to take. So the idea of using one of the other keywords. And so again, just keep in mind that the statement after the then only executes if the Boolean test is true. So I want you to take a moment. I want you to mull over this slide. I want you to pause the video and think about what would happen if grade is equal to 95. What would be the result of grade after it executes all of these lines of code? So if we go through this statement, so line 10 says if grade is greater than or equal to 95. Well, that's true. So it stores in memory score as A. So then the next executing line of code, this line 20 is going to execute regardless. And so it is true that 95 is greater than 80. So it's going to overwrite score in memory as B. Is grade greater than 70? Yes, it is. So it overwrites it with a C. Is grade greater than 60? Yes, it's true. So it overwrites score to equal D. Is grade less than 60 is false. So then it will not execute the idea of score equaling 50. So this is going to output a D for us, not the A that we would assume. And why is that? And that's because all of these if statements are independent of each other. Every single line of code here is going to execute. And so regardless of the outcome of the first line, the next line will also be true. And so order is going to matter in the testing. We will see throughout this chapter several ways of rewriting this code so that it gives us the appropriate outcome. So let's talk about the logical operators and the idea of a compound statement. You used compound statements in algebra using the and or the or. So we're going to take a look at combining these ideas together. So a compound conditional if statement is when I take two tests or more related conditions for an action to take place. So for example, if you're 16 years of age or older and pass the written test, then you can get a learner's permit. So the idea that there is a multiple set of conditions that need to be true in order for me to be able to get my learner's permit. If the car is out of fuel or the battery is dead, then the car will not turn over. So I've added a layer of condition here in my testing process to determine whether or not the car will turn over. So we have two logical operators. The first keyword is the word and. And is used to connect more than one relationship in the same if statement. What you need to understand is that all statements must be true in order for it to execute. So in the example, if average is greater than 89 and courses is greater than or equal to 5, then print you made the dean's list. So if my average is not greater than 89, then I can't make the dean's list. Doesn't matter how many courses I'm taking. If I have an average of over 89, but I'm not carrying 5 or more courses, then I can't make the dean's list. So in another example, if age is greater than or equal to 35 and the idea of being a citizen is yes, then it will print that I can be president of the United States. But if either one of those conditions is not true, then I can't be the president of the United States. So let's talk about the truth table of the and operator. And so if I have element A and element B with the idea that A and B represent this test condition, okay, very similar to what we had in the previous statement. So like if this were test A and test B, the outcome here for having a and B test of and, if A is true and B is true, then the outcome will be true. If A is true but B is false, then it can't have a true outcome. If A is false and B is true, then I'm also going to have a false outcome. And if A is false and B is false, then I'm certainly going to have a false outcome. With the idea that only one time can the action actually execute when both of them are true. Now, something that you need to understand is this idea of short circuiting. So under this condition with A being true, it has to test the B condition to determine whether or not the outcome will be true. But if the A condition is already false, then it will short circuit and it will not test the B condition. It will short circuit here and not test the B condition because it doesn't need to. It doesn't matter what B is if A is already false under the A and scenario. So I've changed my grade program to now test the range. So this is testing a range of values. If grade is greater than or equal to 90 and it's also less than or equal to 100, then I'll get an A. But if either one of these is false, then it's not going to execute the then statement. It will fall to the next test. So if grade is greater than or equal to 80 and grade is less than 90, then the score will be B. and so on, testing the ranges. And by testing the ranges, then I'm guaranteed a match at some point along the way. Again, these are still independent of each other, okay, but it will only choose one of these outcomes because a number can be greater than 90 and also less than 100, but it can't be greater than 90 and also less than 80. So you have to think about the possibilities. And we did this in algebra class, this idea of this compound statement, when it graphed to be within the range. Okay, and this was an and scenario where I was looking for the overlap. Under the or scenario, only one of the two outcomes need to be true in order for it to execute. So we're still looking at the present one, but I wrote the outcome in a little different arrangement. If age is less than 35 or citizen is not equal to yes, then print you can't be president. Well, if it's true that age is less than 35, I can't be president. So, or if, let's say I am older than 35, but I'm not a citizen, then I still can't be president. So we've written what we would consider the negation of my original statement in the and scenario, with the idea that only one of these needed to be true in order for the statement to be true. But I used the negation, the opposite of what my other test was with the and. So for the truth table for or, we're looking at, again, the same idea. Is A true, true, false, and false. This is giving us the idea of all possibilities. So if A is true and B is true, the outcome is true. If A is true but B is false, I only need one or the other, so I still get a true outcome. If A is false but B is true, okay, it has to test because it's an or, it's going to test. It's not going to short circuit. It will test to see, well, maybe I still have a true outcome. And so I still have a true outcome. The only time under an or that I'll get a false outcome is if they're both false. So we can see that there are three possible outcomes with the or. Under this scenario, when will it short circuit? It actually will short circuit here because it doesn't matter whether or not they're false. It needs to test the other outcome over here in order to determine, is the other possibility valid? So the short circuit happens under different scenarios in the or table. So what happens if this condition isn't true, but maybe I want to take another action instead? And so we have the enhanced decision structure. If this is true, then do this, else do something else. So it's giving me a second alternative action if the case is false. So the alternative action following the else is taken if the test condition itself is false. So if the average is greater than 89 and courses is greater than or equal to 5, then print you made the dean's list. So if these are both true, then the then will happen and I can make the dean's list. Remember, this is an and, so there's only one case in which it can be true. So if this is true but this is false, then it's going to produce the else outcome because I didn't meet both conditions. So even if this is false, no matter whether or not this is true or false, it will do the else action for us. So we've taken a look at the and, the or, the enhanced decision structure as it relates to the relational operators in testing a condition. In this case, again, the idea that average is 90, courses is 6, I've made the dean's list. But if average is 85 and courses is still 6, I didn't make the dean's list.